In a calculus class, this differentiation table you have to memorize by heart. So differentiate a constant. So this C represents any constant. It's a derivative, or differentiate, which means dc could be over dx, right? Imagine C is a function of x, but it equals to a constant value. So that's always 0, right? But I'm not going to write in this case, but you understand, right? Differentiation or derivative is just d of the variable over another variable. So I'm going to keep it simple because I'm meant to make a table list. So differentiation, sometimes we call this prime, C prime, right? So it has a couple of names, right? Derivative of C, differentiation C, C prime, right, equals 0. So what is the differentiation or derivative or prime? Which means the rate of change, right? So what is the rate of change of a constant? It doesn't change, that's why it's 0. Then we have this power rule, right? For exponents, if the variable raised by n is a derivative, it's just n times x raised by the power n minus 1. Then sine cosine, derivative of sine or sine prime equals cosine. And cosine derivative is not sine, but negative sine. Derivative of e to the x is itself. Derivative of, so this is Euler number. Euler number is like a pi, a constant number. If you plug into a calculator, you get a 7.2. It keeps going on. It's an irrational number. So we just keep as e, as an Euler number. So its derivative is itself. That's marvelous, right? If it's any other number, it's any other positive number raised by x, we still get itself, but has to have ln a. So just one more comparing to e to the x, we have to multiply by ln a. Here actually we have ln e, but what's ln e? It's 1, because ln means base log base e. Then we have some, let's see, we have x multiplied by a function, f of x. So product, right? So x multiplied by a function. So its derivative is taking the derivative of the first one, well, just 1. Derivative of x is 1. So 1 times f of x. Then derivative of x prime times, no, not f, derivative of x, not derivative, just x times the derivative of f, which is f prime. So take the derivative of f, that's f prime, times f of x. Then if we change this to be x squared, let's see, x squared times f of x, because we often use those ones, right? Derivative of x squared is 2x times f of x. Then plus x squared times derivative of f of x. And what about the e to the x, f of x? Take a derivative of this. Because derivative of e to the x is e to the x. This is itself. Then we have f of x. Then plus e to the x times derivative of f of x, which is f prime of x, which means we can factor out e to the x. Then with a quotient, let's say we have f of x divided by x, so this quotient, okay? By quotient rule, so we have derivative of the numerator, which is f prime of x, times the denominator, which is x, then minus the numerator, f of x, times the denominator, derivative of the denominator, which is just 1. So that's a minus f of x. Then divided by x squared. If we want to simplify this a little bit, we just get f prime of x divided by x minus f of x divided by x squared. If we remember this table by heart, so when we in the calculus class, we will calculate faster.